Hello, in this video I'm going to talk about unit cells. There are three different types of cubic structures, such as simple cubic, body-centered cubic, and face-centered cubic. Each one of these structures represents a single unit cell. Each structure has its own atom number, coordination number, edge length, and volume. First, I'm going to talk about the simple cubic structure, or SC. Notice in the top left picture, each corner of the unit cell has 1/8 of an atom, and since there are 8 corners in a cube, we multiply 1/8 by 8 to obtain the number of atoms, which in this case is 1. The coordination number of a simple cubic structure is 6. The picture on the right represents how every corner atom is surrounded by 6 other corner atoms. The edge length is 2r, and it's represented by the bottom left picture, with r being the radius of an atom. The volume is calculated by the ratio from the volume of the atoms and the volume of the cube. To find the volume of the unit cell, first we find the volume of the cube, which is length times width times height. Since the length of one side of the square is 2r, 3 times 2r is 8r cubed. Then we find the volume of the atoms, that being the number of atoms times the volume of an atom. The volume of an atom is 4/3 pi r cubed. After solving the formula, we find that the percentage of volume of atom in the simple cubic structure is 52.36%. Next, the body-centered cubic structure, or BCC. The picture in the top left corner shows how one whole atom is attached to the center of the cube, making the atom number go up to 2 atoms. The coordination number is 8, and the picture on the right gives a better image of how the 8 atoms are arranged around the center atom. The edge length is 4r over the square root of 3. In the picture of the bottom left shows how the longest diagonal, represented by the blue line in the middle, is 4r. That value can be obtained from the bottom corner of the cube all along the center until reaching the other corner. As we can see, the blue line forms a right triangle with the hypotenuse of the green triangle. The hypotenuse of the green triangle is represented by L, and the sides of that green right triangle are x, which represents 2r. Focusing now on the blue right triangle, L squared plus x squared equal to 4r squared. Substituting L squared into the blue triangle equation gives the edge length of this structure. The volume is again the same ratio of volume of atoms and volume of cube. In this case, the volume of atoms is multiplied by 2, and the volume of the cube comes from multiplying the edge length of 4r over the square root of 3 times. After solving the equation, the volume of the body-centered cubic structure is 68.02%. Last but not least, face-centered cubic structure, or FCC. There are 4 atoms in this unit cell, and it can be calculated by multiplying half atom times 6 faces of the cube plus 1/8 times 8 corners of the cube. As we see in the left corner picture, there are atoms at the center of each face of the cube. The coordination number is 12, and it is calculated by how many atoms are adjacent to the face center atom. In the picture on the right shows how one face of the cube is adjacent to all 4 corner atoms and 4 face center atoms in each side. The edge length can be calculated using the Pythagorean theorem. Represented in the bottom left picture, the orange triangle is a right triangle. In this case, D is the hypotenuse and the value is 4r. After plugging everything into the equation, the edge length is 4r over the square root of 2. With the edge length, we can find the volume of the cube, that being 3 times that value. To find the volume of the atoms, this time we multiply the volume of an atom by 4. After solving the equation, the volume percentage of the face-centered cubic structure is 74.05%. In this slide, I posted a short little video of each 3D model I created for this assignment.